In the mid to late 80s, there was an operation to the south here called the double oxide. It was a two-man show. It was a high-grade copper, a native copper zone. And they began the production, I think, in the mid-80s, and it finished in about 1991. And when I actually went and had a look at what they were doing down there, they were actually bringing up pure metal out of the ground, and at an average grade of about 44%. They produced about 390 tonnes from about 890 tonnes of ore. That was the DNA for something that was going to be really, really good. So for the first 18 months, we literally ran with one RC rig and one diamond rig. So we couldn't drill as quick as we wanted to. And the market punished us a little bit for that because they couldn't understand, why is it going to take, all this time to bring out a resource? We didn't want to bring a resource out until we knew what we had, or had a good idea of what we had. There was no point bringing out a half-baked resource until we could get the drill rigs. We couldn't do that. In the end, when we could get drill rigs, when the boom was over, we ended up with 16 drill rigs out here. And we completed the same amount of time that took 3.5 years we did in 7 months. Currently now, we are operating with 5 rigs on site. There's 3 diamonds and 2 RC rigs. The RC rigs are capable of drilling about 300 metres a day, and the diamond rigs between 30 and 50 metres a day.
RC is reverse circulation, so you've basically got a tube within a tube. Now, inside the outer tube, you force air down, and it reaches a point at the bottom of the rod called the hammer.
And it hammers its way into the ground at the rate of about 300 metres per day. The air has nowhere to go while it's hammering down. The air has nowhere to go except up these 2 holes here. So it's got nowhere to go. So it gets blasted down the outside, and then the product then goes up at these holes, goes up the 300 metres to the rods, and comes out as a sample at the top.
The thing is with RC is the annuluses in the actual hammer bit are about 25 mil. So it's going to limit the size of particles that can fit up through the rod string. With diamond core, of course, you don't have a problem because it essentially cuts a cylinder of core as it was in situ. So you actually get to see exactly how the minerals are in relation to other minerals, in relation to the structures in the ground.
This product that comes up gives a real insight into actually what we have down there, rather than the pulverised dust that comes up in an RC rig. However, this is acceptable for the JORC.
A couple of things that we have noticed in recent times, and probably even earlier, that we have noticed that some differences between the diamond core assays and the RC assays.
We had to send a lot of large core, PQ core, 4.5 inch PQ core to Western Australia, to AMDEC, to do the metallurgical test work. When they're breaking this large core to do the test work for the grinding and the crushing test work, they found that the metal inside, up to 50% of it was bigger than 35 millimetre. Now these obviously aren't going up the hole to be assayed. The size that do go up the hole are the smaller pieces. So when this is blowing the air down, these smaller pieces that are being pulverised are going up and being assayed when they get to the top. What we don't know is how much of it is this size that's not going up the spout. To try and assess a resource like this, a native copper resource, to be definite and more accurate, the RC rig is probably not the best thing. However, we drill with it, not knowing that there was larger nuggets down there. Now we may end up with nuggets this size.
One day we had to stop the RC rig because it wouldn't drill any further, and we brought it up and it had a plate covering the whole bottom of the hammer, which prevented any material from getting back up the sample hole.
Of 600 samples, all drilled in the same area, roughly half-half diamond RC, the result of looking at these and results from the lab is that the proportion of coarse copper metal weight out of the total weight of the sample is less in RC than it is in diamond, and less by a factor of maybe 20 to 50%.
For that reason, we don't believe that the recovery of native copper in the RC sampling has been anywhere near as high as the diamond core.
people can't understand, with all these high grades that we're getting, why isn't it higher? Well, in the calculations, when they're done using the geological programs, they have things like kriging, they have things like smoothing and variography. And when you have a grade that varies more than 10%, and by that I mean 2% to 12%, the programs really can't cope with it. They're not made designed to calculate ore bodies like this.
There's 4 key mineralised zones. There's the oxide zone, which is near surface, the native copper zone, which is below the oxide zone. You get a supergene chalcocite zone, and then you get primary. Basically, as you go down through those zones, the amount of weathering influence decreases. So the native copper zone and the chalcocite zone, the supergene enrichment zone, have formed as a result of the dissolution of copper minerals and the increase in grade associated with the redeposition of those copper minerals and in cases changing the mineralogy on the way down.
This was once a piece of magnetite or iron ore. It's now been replaced with copper.
The silvery mineral here is chalcocite. That's a bit over 79% copper, and that is from the supergene chalcocite zone, and that's between the native copper zone and the primary zone. Another one we have is, this is from the primary zone. This is chalcoborite. It's got about 34% copper, and that's from hydrothermal breccia. And of course, we have some native copper, which is this is exactly what it's like on the ground, coarse copper metal.
We have these large nuggets down there. How big they're going to be, we don't know. But I think the heaviest one so far is about 15 kilos.
It's average on assays that we've had done so far on clean copper metal, 99.65% copper.
The native copper has been found as shallow as about 3 metres and as deep down as about 110 metres straight down. The richest zones occur at around about 20, 50 and 70 metres of native copper, and that's going to form the richest part of our deposits.
This is mainly in what we call the bonanza zones, which is about 500 metres to 600 metres at southern Rocklands, and there's 400 metres of very high grade at central Las Mineral, and then there's about another 400 metres of still high grade but not as high as what we call the jewellery box.
The geology at Rocklands is, it's really phenomenal. We've got copper grades up to 58%. We've had cobalt in several places over 1%. We've got gold grades up to over 60 grams a tonne. You know, there's a lot going on here. The geology is, it's coarse mineralisation. It's just brilliant.
One thing that these ore bodies have here is a lot of cobalt, and a high-grade cobalt as well. Cobalt is a very rare mineral. It's rare because of the heat that it can actually be able to withstand. Like jet engines are made of cobalt.
The use of cobalt is increasing, particularly in batteries that are used in hybrid cars, which are becoming more and more prevalent in the marketplace, in the aerospace industry, and some of the special alloys that are used, and there's still a strong demand for cobalt in the agricultural industry, where it's used a lot for supplementing stock feeds and other agricultural requirements.
Mineralisation at Rocklands in almost all ore bodies starts from surface. So as soon as you start breaking ground, you're already into ore. So that's for La Mineral, South Rocklands, Rocklands Central Meridian, Las Mineral East, the Northwest, the Windmill, Raindon, they all start from surface. So you're right into it from day dot.
The pit optimisation, just the preliminary stuff, is showing a strip ratio of about 2.55 to 1. So for every 2.55 tonne of waste we take out 1 tonne of ore.
The planning for the mine is to mine the higher grade areas to start with in Las Mineral and Central Rocklands, and we have been developing our whole test work program to be able to process that material efficiently and get some really high cash flows in the early years of the project.
The geological resource is 1.24, average over 10 years, which is 37,000 tonnes of copper per year. However, we are not building our plant to treat that. We're building our plant to treat 5 to 7% copper, because we think a lot of the native copper is going to come out in the larger form, and we're building a gravity plant up the front to take advantage of the native copper. The 3 million tonnes a year of throughput through the processing plant is based on a total resource of 31 million tonnes at 1.24. However, the current JORC guideline report is indicating to us that the first 4 years is going to average around 2%, 2.05% copper equivalent. So 3 million tonne a year is going to deliver around 60,000 tonnes of copper equivalent per year for the first 4 years. Then from after that, it will deteriorate slightly. However, what we really think we're going to mine will be in excess of that. Our timing will be perfect. We'll be going into production around the end of 2012, and I think the cobalt, the copper price, everything will be perfect for us. Apart from having a good resource like we have here at Rocklands, one of the other most important things you need is good infrastructure. Now, in the case of Rocklands, we're 15 kilometres from a major town, we're 15 kilometres from rail, we're 4 kilometres from the major highway that runs around Australia. We have ample underground waters to sustain a 5 million tonne a year project at this stage. We have electricity that's close by, within 7 kilometres. We're lucky we have a smelter at Mount Isa Mines, which is about 100 kilometres from where I'm standing at the moment. So we have a choice to either sell our product to Mount Isa Mines, or we have an option to export it. Now, to export it, you need a couple of things. First, you need a railway siding or a spur line, which we have. We have access to the rail, and we now have a port facility at the Townsville port, and we've managed to pick up around $40 or $50 million worth of equipment at a very low price. So we now own all of our own mining equipment. That includes all of the dump trucks, the dozers, the loaders, the excavators. So we're ahead of the game.
Some of the advantages of where we are at Rocklands in relation to the development of the project, firstly, and it's a big advantage, the proximity to town. We won't be required to have a full village infrastructure to be built on the site here. We hope to be able to integrate the workforce in the town. We hope to be able to employ locally. Our whole strategy is to encourage people to come and live in Cloncurry. We don't want to get into the fly-in, fly-out syndrome. We hope to just develop a better lifestyle for families who want to come and live in Cloncurry and work for us.
This will be the only asset of CuDECO. There'll be enough mining here for the next 40 or 60 years on what we've found so far.
We don't have a big black hole project coming up in the future which is going to soak up all the profits that are going to be generated by Rocklands. Therefore, the shareholders are going to benefit by having all that profit returned to them as a dividend. And I think anyone who's going to have that money in a super fund is going to be generously rewarded down the track.
I would rate this project, the Rocklands projects, as one of the most exciting projects that I've ever been involved with.
It's been quite a challenging prospect, but also very exciting because of what we've seen coming up out of the ground day after day after day.
There's geophysical signatures that suggest there could be something very big under there. I'm very excited.
This deposit is unlike any other deposit in Australia. There is no other deposit in Australia that delivers 99.8% pure metal out of the ground. Trying to comply with the JORC guidelines for a deposit like this is difficult.
I don't think there's anywhere I'm going to go and see native copper like this again. Never.
This project is a fantastic, a great project, and I won't let you down.